Finally, let's take a look at the situation where you have 6 groups of electrons are sticking out of your central atom. So you're dealing with a steric number of 6. So this is how they will be oriented. This is called an octahedral center. An example here is SF6. So your sulfur would be here in the middle, central atom. Okay, and you have 6 fluorines around it. So it will be an octahedral center. Okay, so when you have steric number of 6, the center is called an octahedral center. You may be asking why octahedral. Well, imagine this is like similar to a trigonal bipyramid, except that the base here is a square. So you can think of this as a square bipyramidal. So you have a square over here, right? And then imagine you have a pyramid, a pyramid with a square base. Okay, and then another pyramid down here. So look, you got 4 triangles on top. You have also 4 triangular faces at the bottom. So you have 8 sides. So if you trace the corners of the molecule, you will be forming a solid that has a shape with 8 sides. 2 square pyramids, 1 pointing up, 1 pointing down. So 8 is octa. So octahedral is an 8-sided solid figure. Okay, so your sulfur here is what we would call an octahedral center. The shape of the SF6 molecule is also octahedral because you have 6. You can each one of those 6 electron domains has an atom at the other side. So to describe the shape of a molecule, you describe the figure, the geometric figure that is. That would be traced by the location, defined by the location of the atoms. Okay, so sulfur is an octahedral center. The shape is also octahedral. This is type AX6. There are 6 atoms attached to the central atom. We say the coordination number of your central atom, which in this case is sulfur, is 6. There's no lone pair in the sulfur. How did we figure out that SF6 has 6 groups sticking out of it? Well, sulfur contributes 6 valence electrons. It's in group 6A. Each fluorine contributes 7. It's in group 7A. So times 6, that's 42 valence electrons from the fluorine plus the 6 from the sulfur. That gives you 48 valence electrons that you need to show in your Lewis structure. Okay, so if you have 48 valence electrons, let's surround the sulfur by 6 of the fluorines. 1, 2, 3, 4, 5, 6. Each fluorine is going to have 3 lone pairs in addition to the single bond to get an octet. So we have 6 of these fluorines with an octet. 6 times 8, that gives you 48. Okay. Fluorine here. Okay, so those 6 fluorine atoms, to stay as far away from each other as possible, take on what's called an octahedral geometry. Okay, notice your sulfur here has, each of your fluorine has a formal charge of 0 for the fluorine, because a free fluorine atom would have 7. Each fluorine atom here appears to own 6 from the lone pairs. That's 3 lone pairs plus 1 from the bonding pair appears to own 7. 7 minus 7, that gives you a 0 formal charge. The sulfur is involved in 6 single bonds. 1, 2, 3, 4, 5, 6. It has no lone pairs. Half of the 6 pairs would be 6 electrons. So it appears to own 6 electrons. A free sulfur atom would have 6 electrons. So the formal charge of sulfur here is 0. So this is a good structure for SF6. Okay. Moving on. If one of those groups happens to be a lone pair, then, so here's your octahedral, and all of those group locations are equivalent. Okay. You'll notice each group is perpendicular to 4 other groups. Okay, so like for example, this group is perpendicular to this one, this one, and that one, and it's 180 degrees from one other group. So all of those groups are the same. Like this group right here is perpendicular to this, that, and that. So that's perpendicular to 4 other groups and 180 degrees from the other group. So all of these groups are equivalent. So a lone pair will take up any one of those positions. So if this becomes a lone pair, what's left behind would look something like this. That gives you a square pyramidal structure. The shape would be called square pyramidal, and this is the case for BRF5. So your bromine would be right here in the center. You'll have fluorine on each of these corners right there. So that's BRF5. Okay, so this is a type AX5E. There's a coordination number of 5. There's 5 fluorines attached to the bromine. So the bromine has a coordination number of 5. And you have 1 lone pair. So this is type AX5E. Now, what happens if you have 1 more lone pair? Then that second lone pair is going to take a position that's opposite the first lone pair. Okay? So if you have AX4E2, you now have 2 lone pairs. Okay? So the first lone pair takes any position. The second lone pair will take the position that's opposite the first lone pair. So what's left behind is a square planar shape. So ClF4 minus, that ion will have a square planar shape. It's type AX4E2. The iodine here, oops, that should be the fluorine, sorry. The chlorine right there. ClF. The chlorine is still an octahedral center. There's still 6 groups sticking out of the chlorine, except that the 5th group is a lone pair and the 6th group is also a lone pair. Only 4 of those groups end up with an atom on the other side. So ClF4 with a -1 is square planar. So we can continue these arguments for what happens if you have 3 lone pairs. So the third lone pair is going to, so you have first and second lone pair will take those positions. The third lone pair, this remaining 4 will be equivalent to the others. So any one of those remaining 4 can be taken up by the third lone pair. And so what remains, if you have 3 lone pairs, AX3E3 will be T-shaped. Okay? And if you take if you have another lone pair, if you have AX2E4, that next lone pair is going to be taking the other opposite of the third lone pair. So what leaves that leaves you with just a linear shape. Okay? In all of these cases, you have an octahedral center with 6 groups sticking out of your central atom. So how did we figure out ClF4 minus has 6 groups sticking out of it? Okay, so let's do Cl, 7 valence electrons because it belongs to group 7. A, it's a halogen. Fluorine has 7 also. There's 4 of them. That gives you 28. And then -1 charge, that means 1 more electron. So 28 plus 7 plus 1 would be 36 electrons. All right. So Cl with 4 groups around it. Okay, 4 fluorine atoms around it. Each fluorine atom gets an octet, so you need 3 lone pairs on each of the fluorine atoms. So you have 4 octets around the chlorine. Okay, so that's 4 times 8. That's only 32. We have 36 valence electrons, so we need 2 more lone pairs on the chlorine. That makes 34, and that makes 36. So ClF4 with a -1 charge is an ion with a central atom with a steric number of 6. So it's got an octahedral center.